The northern lights, also known as the Aurora Borealis, have captivated humans for thousands of years. From ancient myths and legends to modern scientific inquiry, this breathtaking natural phenomenon continues to inspire wonder and awe. Dancing across the night sky in shades of green, pink, purple, and sometimes even red or blue, the northern lights offer a spectacle unlike any other, a celestial display that seems almost magical in its beauty and mystery. But behind this enchanting light show lies a fascinating story of science, space, and the Earth's connection to the Sun. Imagine yourself standing on a cold winter night in a remote area, far from the lights of any city. The air is crisp, the sky dark and clear, and as you look up, something extraordinary begins to happen. A faint glow appears on the horizon, slowly intensifying until ribbons of light start to swirl and twist across the sky. These luminous waves of color move as though they are alive, shifting and changing in an unpredictable dance. For anyone lucky enough to witness the northern lights firsthand, it is an experience that can feel otherworldly, as though the sky has been set alight by some unseen force. For centuries, people have been fascinated by the northern lights and have sought to explain them in various ways. In Norse mythology, the lights were thought to be reflections from the shields of the Valkyries, the warrior maidens who carried fallen soldiers to the afterlife. The indigenous Sami people of northern Scandinavia believed the lights were the souls of the departed, dancing in the sky. Other cultures, from the Inuit to the ancient Chinese, had their own interpretations of the lights, seeing them as anything from fiery dragons to divine messages. While the myths and legends surrounding the northern lights are intriguing, the real explanation for this natural wonder lies in the realm of science. The auroras, both in the north, Aurora Borealis, and the south, Aurora Australis, are caused by the interaction between the Earth's magnetic field and charged particles from the Sun. These particles, known as solar wind, are constantly streaming out from the Sun's surface and travel across space at incredible speeds. When they reach the Earth, they are funneled toward the poles by the planet's magnetic field, where they collide with atoms and molecules in the atmosphere. These collisions release energy in the form of light, creating the spectacular colors and patterns we see in the sky. The process that creates the northern lights begins on the Sun, where massive explosions called solar flares or coronal mass ejections send streams of charged particles hurtling through space. These solar winds are made up of electrons, protons, and other particles that, when they reach Earth, interact with the planet's magnetosphere, the region of space dominated by Earth's magnetic field. The magnetosphere acts as a shield, protecting the Earth from much of the harmful radiation carried by the solar wind, but at the poles, where the magnetic field is weaker, some of these particles manage to enter the atmosphere. Once these charged particles reach the atmosphere, they collide with atoms of oxygen and nitrogen, the two most abundant gases in Earth's atmosphere. These collisions cause the atoms to become excited, which means that their electrons are temporarily boosted to higher energy levels. When the electrons return to their normal state, they release energy in the form of photons, tiny packets of light. The color of the light depends on the type of gas involved and the altitude at which the collision occurs. For example, oxygen atoms produce green and red light, while nitrogen molecules can create blue and purple hues. The result of this process is the northern lights, a display of shimmering, colorful lights that can vary in intensity, shape, and movement. Sometimes the lights appear as soft, glowing arcs or curtains that stretch across the sky, while other times they form swirling patterns or rays that shoot upward like pillars of light. The lights can be faint and subtle, or they can burst into vibrant, pulsating waves that fill the entire sky. The unpredictability of the northern lights is part of what makes them so mesmerizing. No two displays are ever exactly the same, and even seasoned aurora watchers never know exactly what to expect. The colors of the northern lights are one of the most striking features of the phenomenon. The most common color is a bright, almost neon green, which is produced when oxygen atoms in the atmosphere are struck by high-energy particles. This green glow usually occurs at altitudes of about 100 to 300 kilometers, 60 to 190 miles, above the Earth's surface.
In addition to green, red auroras can also be seen, though they are less common.
These red lights are also produced by oxygen, but at much higher altitudes above 300 kilometers, 190 miles. Meanwhile, blue and purple auroras are created when nitrogen molecules are excited, and these colors often appear at lower altitudes, below 100 kilometers, 60 miles. One of the most fascinating aspects of the northern lights is their ability to change shape and move. The lights are constantly shifting and undulating, sometimes slowly drifting across the sky in graceful arcs and at other times bursting into rapid, flickering patterns. This movement is caused by the interaction between the solar wind and the Earth's magnetic field. As the charged particles are funneled toward the poles, they follow the lines of the magnetic field, which can cause the lights to form into shapes that mirror the structure of the magnetic field itself. The movement of the solar wind and fluctuations in the Earth's magnetosphere can also create more dynamic displays, with the lights appearing to dance or ripple across the sky. The northern lights are most commonly seen in regions close to the magnetic poles, such as northern Scandinavia, Canada, Alaska, and Russia. However, under the right conditions, they can be visible much farther south. During periods of high solar activity, when the sun releases large amounts of charged particles, the auroras can extend to lower latitudes, reaching as far south as the northern United States or parts of Europe. Conversely, the southern hemisphere experiences its own version of the auroras, known as the Aurora Australis, which can be seen in places like Antarctica, southern Australia, and New Zealand. The best time to see the northern lights is during the winter months, when the nights are long and dark, and the sky is clear. In the Arctic regions, where the phenomenon is most frequent, the long winter nights provide the perfect conditions for aurora viewing. In places like northern Norway, Sweden, Finland, and Canada, the lights can be seen regularly from late September to early April. However, seeing the northern lights is never guaranteed, as their appearance depends on a variety of factors, including solar activity, weather conditions, and the level of geomagnetic disturbance in the Earth's atmosphere. For many people, witnessing the northern lights is a once-in-a-lifetime experience, and it is often at the top of travelers' bucket lists. The sight of the sky coming alive with color and movement is something that leaves a lasting impression, a reminder of the beauty and mystery of the natural world. In recent years, tourism to areas where the northern lights are visible has grown, with visitors flocking to destinations like Tromsø in Norway, Yellowknife in Canada, and the Lapland region of Finland in the hopes of catching a glimpse of the aurora. Many tour operators offer special northern lights excursions, where travelers can stay in remote locations far from light pollution and increase their chances of seeing the lights. For scientists, the northern lights are more than just a beautiful spectacle, they are a window into the workings of space weather and the interaction between the sun and the Earth. By studying the auroras, scientists can learn more about the solar wind, the Earth's magnetic field, and how energy from the sun affects our planet. This research is important not only for understanding the natural world but also for protecting modern technology. The same solar particles that create the northern lights can also disrupt satellites, communication systems, and power grids, particularly during intense solar storms. By monitoring solar activity and studying the auroras, scientists can better predict when these storms might occur and take steps to minimize their impact. One of the most fascinating aspects of the northern lights is their unpredictability. While scientists can forecast when the lights are likely to be visible based on solar activity, there is still an element of chance involved in witnessing a truly spectacular display. The lights can appear suddenly, then fade just as quickly, or they can persist for hours, lighting up the sky in a continuous dance of color and movement. This sense of unpredictability only adds to the wonder of the northern lights, as each sighting feels like a rare and special event. The auroras have also inspired art, literature, and music throughout history. Many artists have tried to capture the beauty of the northern lights in paintings, photographs, and films, though no artistic representation can fully convey the experience of seeing them in person. Writers and poets have often used the auroras as a metaphor for the mysterious and fleeting nature of life, while composers have created music inspired by the light's shifting colors and patterns. The northern lights evoke a sense of wonder and awe that transcends scientific explanation, reminding us of the vastness of the universe and our small place within it. Despite all we have learned about the northern lights, they still retain an air of mystery. There is something about their ephemeral nature, the way they appear and disappear without warning, that keeps us captivated. The lights remind us that even in our modern, technology-driven world, there are still phenomena that defy our understanding, that make us stop and marvel at the beauty and complexity of the natural world. As our understanding of the northern lights continues to grow, so too does our appreciation for the delicate balance of forces that creates them. The auroras are a reminder of the interconnectedness of the earth and the sun, of the invisible processes that shape our world, and of the power and beauty of nature. They are a testament to the wonders of our universe and a source of inspiration for all who have the privilege of witnessing them.